Pardon me?
5, 10, 15, 20.
Okay, so what do you see?
Right here, 5 plus 5 plus 5 again. That's 12.
So you're noticing 5. So what is that called when you do that?
Add 5.
Okay. So where do you start? Start at?
Start at 5 and add 5 each time.
Okay. And what is the pattern? What are you noticing? How would you say that? The way it sort of is structured.
Start at 5 and add 5 to 10, and then add 10 to 5.
Okay. And then where do you go?
20,
Okay. Then what happens?
and then the pattern stops.
Okay. So color that in and see if you can find that anywhere else on there. See if you can find that same type of pattern. Could you tell Sharday what you found there? See if she can find it as well. And maybe Nevaeh, see if you can find something similar. Explain to them what you're doing.
So right here there's 5. So 5 plus 5 is 10. Then if you add 5 to 10, you got 15. And then if you add 10 to 5, you get 12. 5, 10, 15, 20.
So add 5.
Add 5 to 15.
Add 5.
And add 15 to 5, you get 20. It's counting by 5 each time. Like start at 5 and add 5 each time.
Okay. Now is there any other pattern like that? Does it continue past that point?
Nope.
Huh. I wonder if you can find any other little pockets that have that. That's interesting. Shade that in there. I'm wondering if we can find anything else like that. So what's that called when you add on 5 each time?
Counting by 5.
Okay, counting by 5s or skip counting by 5s? Sure. Can you find that? Find that on yours. Sharday. Can you see anything else like that where it starts with a number and then what do you notice? What do you notice about all of these numbers? What do you notice about all of those numbers?
It's in a pattern.
Okay, yes, I see that pattern. What else do you notice about all those numbers? There's something special about all of those. See if you can find it. There's something special about all of these numbers. Can you figure out what it is?
Like right here. Oh wait, this is 1, 5, 10, 10, 5, 1.
So what do you notice about those?
It's like the number over. It's like 1, 5, 10. 1, 5, 10.
So what is
You
that?
repeated the number backwards.
What is that? Can you find the middle of each one? Like you just said, where would the middle of that pattern? What is that called? A line of... Right. Is there any more lines of symmetry on that?
You gotta add 7 3 times to get 21.
Okay. Can you find anything else? 7 times 3 is 21. What did you find? Right. Are there any more? Anywhere else?
Wait, 136, 84, 126, 84, 36, 91.
So put a line at the center of each one that you find, and then
I shouldn't get one in. Yeah, I'm just
put a line down the center like you did before.
I shouldn't get one in.
Pardon me? Yeah, put it on another one so we can see it clearly. Good job.
Maybe I use a Canadian pattern, so it's like 1 says 2 equals 3.
So it's a pattern. You start at 1, add 3, and then increase by 1 time. Add 3. So this is adding 3. Adding 3 and then adding 4 because it's 3 plus 1, 4 plus 1, and then
So how would you say that in a pattern rule?
start at 1, add 3.
What are you adding there?
3.
So start at 1 and add 3. What's 1 plus 3?
Wait, 4.
So is it 4?
No.
So what?
One
No,
plus
it's this
2.
one.
Oh, so start at 1. Continue.
Add 2, which equals 3. Plus 1. Plus 2 plus 1, which would be 6. Plus 3 plus 1.
How are you going to say that in a pattern rule?
Um,
Maybe create your T-chart and see if that helps you. Because remember, when we organize our work in a T-chart or in a table of values, it helps us to see patterns better, right? And when you show me the difference between each one, I think you're going to be able to make the rule better.
What hockey stick?
what is a hockey stick?
What is a hockey stick?
Most of you are hockey player or soccer players. What does a hockey stick look like? Describe it to me.
A flat.
Yeah. Yeah, so it's not like it's like a hockey stick goes like this, and it's kind of goes like that. It's not like an L. It's slanted down a bit. So that might be a little clue for you, because some people don't know what a hockey stick looks like. We got.
Okay, tell me what you found.
So we found out that there's 2 4s on each side, and then there's 6 and no, never mind.
So the
So
black
all-
ones aren't prime numbers.
So we're trying to find if there's
Sorry, the
any.
black are prime numbers or are not?
They're not.
The reds are.
So the reds are prime numbers?
Yeah.
Gotcha. And why are you coloring in the black ones now? What are you looking for?
So if
You
we
find it easier to find the ones that aren't prime numbers first.
Okay, versus the ones that are. That's a great strategy. I'm coming back to see in a few moments what it looks like.